Okay, guys. Alright, we are on March 23rd. And the name for this is going to be Algebra 1. And we're going to talk about differences, taking the square roots of differences of squares. So, one thing we need to go over again is the factoring. So remember to factor, you can FOIL, which means do the first numbers. X times x would give you x squared. Do the outside numbers. X times a negative 4x would be negative 4x. Now do the inside numbers. And then 4 times x would be a plus 4x. And do the last numbers. So 4 times a negative 4 would be a negative 16. And then if you FOIL, remember to combine these two, which would actually give you 0, so you just have negative x, or x squared minus 16. Another way to do this, if y'all remembered, was to do the box method. So draw your box. Make sure it has 4 spaces. On the top half, we're going to put 5m plus 1. Remember, 5 goes each number above each square. On the side, we're going to put 5m minus 1. And then 5m times 5m would give you 25m squared. 5m times 1 is 5m, and that's a positive 5m. 5m times a negative 1 would be a negative 5m. Negative 1 times a positive 1 is a negative 1. And then remember to combine these two. So positive 5m minus 5m, which you can rewrite them right here, 25m squared plus 5m minus 5m minus 1. This will give you to 0, so then you have 25m squared minus 1. Alright, the thing to note about these is 16, 25, and 1 are all perfect squares. And then your two variables are to an even power, and they're both subtraction. So this is the resulting product. It's called a difference of squares. So it's something that you can take the square root of minus something you can take the square root of. Salem, move. Sorry, that's my cat. Salem! Okay. Alright, so to factor a difference of squares, we have to make sure that we actually have a difference of squares. So make sure there's a subtraction sign. That you can take the square root of whatever comes first. You can take the square root of x squared. You can take the square root of 25m squared. Make sure you can take the square root of the number that comes after the subtraction. 16 and 1, you can take the square root of both of those. Then once you have, once you know that it is a difference of squares, then you can do that this a squared minus b squared would be a plus b times a minus b. And notice on these we had the same thing, 5m plus 1, 5m minus 1, plus minus, same thing, x plus 4, x minus 4, and it gave us this. So we know how to go from here to here. Now we're going to learn how to go from here to here. Once you've factored it, if you're not sure if you factored it correctly, distribute. So if you factored and you're here, go ahead and distribute either by using FOIL or by using your box method. And then if you get back what you started with, then you did the right job. You did good. If you didn't, then you probably went a little bit off on your math. That's okay. You can always go back in and fix it. So we're going to factor each of these difference of squares. We're going to check our work by distributing. If you cannot factor something, you write prime. So a variable to an even power, you can take the square root of that. And 4 is a perfect square. So to find a, in this case, a squared, to find a, you would take the square root of a squared, which is a to the 2 divided by 2, which is just a to the 1. And then the square root of 4. It is 2. You can, since it is a perfect square, you can use your calculator and just find the square root of 4. So then your answer, since we're factoring, we're going to have 2 sets of parentheses. In the first one, since a came first, we'll write the a first. And then one of them has to be addition, plus what was the 4, square root of 4 was 2. Then we're going to write the same thing, a and 2, but this time with a subtraction sign. And that's your answer. So in this case, the square root of n squared, I need a different, give me 1 second. That'd be n to the first. The square root of 64 would give you 8. So in here, another easy way to remember it is n came first before the number, so you put n, 8, n, 8, add, subtract. And that's it. We will not be going through all of these. I have the full posted notes on Google Classroom. I will just explain a couple of them in each little section. Alright, notice number 3, that the number comes before the variable, which is fine, because if you can find the square root of 81, that's going to give you 9. You can find the square root of x squared. That's going to give you x. So draw your 2 parentheses. Since the number came first, we're going to write 9 first this time. So we'd write 9 and then x. 9 and then x, and then 1's addition, 1's subtraction. And that's your answer. Notice number 6. It is different because now we just don't have, now we have another number in front of our variable. The square root of 1, it's 1. The square root of 49y squared. Well, you'd find the square root of 49 first, which would be 7. And then the square root of y squared would be y to the first. So then you draw your 2 parentheses. The number came first. The 1 by itself came first. So you'd write 1 first, and then 7y is going to be second. 1, 7y, and then one of them is going to be addition. The other one will be subtraction. Alright, number 7. Again, we have a number in front of our variable. So, let's find the square root of 9b squared, which is 3b, and the square root of 100, which is just 10. Remember, if you have a number and a variable, find the square root of 9, which is 3, square root of b squared, which is b. So then do your open parentheses, 2 sets. So then you would have 3b, because 9b squared came first, so you'd write 3b first. You could write 3b first, and then 10 second, and then subtraction and addition. That's it. So jump down over here to number 11. Notice now we have a number variable minus a number variable. Well, that's perfectly fine. You just find the square root of 4h squared, because 4 and 25 are perfect squares, and our variables are to an even number. That square root of 4 is 2. The square root of h squared is just h. Then for 25, g squared. The square root of 25 is 5. And the square root of g squared is just g. So then doing your 2 sets of parentheses, our 4h squared came first, so we would write 2h first. 2h and 2h. Then our 5g came second, so that would come out second. And we need addition and subtraction. Alright, now flipping over to the back side. Note that on number 13, now we have x squared, y squared minus 1. So we have 2 variables. But you can take the square root of x squared, y squared, because the square root of x squared would be x. The square root of y squared would be y. And then the square root of 1 again is just 1. So then set up your double parentheses, and you would write xy, xy, and then we had 1, 1. So we need a positive and a negative. Alright. On number 14, notice we have n to the 4th. And we're still to an even power. So if we have a square root of x to the a, then that is x to the a divided by 2, not divided by b. But this is only the case if A is even. So since A is even, in this case our A is 4, 4 is even, so we can still take the square root of that. That would be 81n that would be 81n to the 4th. The square root of 81 is 9. The square root of n to the 4th, that would be n to the 4 divided by 2, which is n squared. Then the square root of 25 is 5. So drawing our two sets of parentheses, we would have 9n squared, and then we would have 5 and 5. Remember, we need subtraction and addition. You can actually write the subtraction first and the addition second. It's perfectly fine. Multiplication is commutative. You get the same answer. But for all of these cases, I'm just going ahead and writing the addition first and the subtraction second. Okay, glance down over here at number 15. We have 4c squared minus 5d squared. 4 is a perfect square, but if you take the square root of 5, you're going to get a decimal. So if you get a decimal, then you are not a perfect square. Since there's nothing more you can do, if you're not a perfect square, then we can't do the difference of squares. So you're prime. Because you're factored down as far as you can go, we cannot factor this any lower. They don't have anything in common either. Okay, notice on number 20, we have 64m to the 4th minus 9n squared. 64 and 9 are both perfect squares. When you take the square root of both of them, you get an even number back, a whole number. You do not get a decimal. And both of your variables are to an even power. So taking the square root of 64m to the 4th, the square root of 64 would give you 8. M to the 4th would be m to the 4 divided by 2, which is m squared. And then the square root of 9n would give you square root of n. Square root of 9 is 3, and the square root is squared. Square root of 9n squared would be just n. So then, writing your two sets of parentheses, 8m squared comes first, 3n comes second, and remember you need addition and subtraction. Okay, these next ones have a greatest common factor. So look for a greatest common factor first, then factor the remaining difference of squares. You can always check by distributing. Notice we have 2n squared minus 72. If you try to take the square root of 2 and the square root of 72, you'd get decimals on both. But also, so they're not perfect squares, but notice that there's a 2 in both of these, because 72 divided by 2 would give you 36. If you take the square root of 36, that is a perfect square. So go ahead and factor out a 2 from both sides. That would leave you with 2n squared divided by 2 would give you just n squared. And 72 divided by 2 would give you 36. Bring down that subtraction. Now notice, you have a subtraction sign. You have a variable to an even power, and you have a perfect square. So now you do have a set of difference of squares. So taking the square root of n squared, that would just give you n. The square root of 36 would give you 6. So then, since we took a 2, the 2 will stay outside of the parentheses. N came first, so n will come first. 6 came second, so you'd write 6 second, and then you need a subtraction and you need an addition. And that would be your answer. Once you've factored something out, it stays out. So it would stay outside of the parentheses. When you go back to distribute, you can use your FOIL method or box method on this first. And then you would end up here. And then you would distribute your 2 and you'd come back up here. Alright, on number 22. Notice we have 18x squared minus 50. 18 is not a perfect square, and neither is 50. But if you take a 2 out of 18, you get 9. And if you take a 2 out of 50, you also get 25. And 9 and 25 are both perfect squares. So go ahead and start by taking out a 2. You would get 9x squared minus 25. Then find the square root of 9x squared, which would give you 3x. And the square root of 25 would give you 5. So you took out a 2, so leave that outside of the brackets, or your parentheses in this case. And then 3x came first, so go ahead and write 3x first. 5 came second, so write 5 on the right. And addition and subtraction. Okay. Glance down at number 24. You have 45q to the third minus 20q to the first. You have a q to an odd power. When you have a q to an odd power, check, do you have a q in both sections? If you say yes, then you can factor out a q. So our greatest common factor in this case is going to have a q in it. Now 45 and 20 both have a 5 in common, because 5 goes into 45, 20 goes into 5 goes into 20. So if you don't remember how to take a common factor out of this, remember you take that first variable, 45q to the third, divide it by your greatest common factor. Well, then that would be 45 divided by 5, which is 9. And that would be q to the 3 minus 1, which is 9q squared. And then you take that second one, 20q, divided by 5q. Since we have q on top and bottom, they cancel out to 1. And then 20 divided by 5 gives you exactly 4. So you factored out a 5q, and you got left with, in the first term, left you with 9q squared. And the second term left you with a 4, and we had subtraction. Now 9q squared, you can take the square root of, and you can take the square root of 4. So the square root of 9q squared would be 3q, and the square root of 4 would be 2. So then remember, once you factor something out, it stays outside. We had a 3q first, because our 9q squared came first, and 2 on the second. Alright, and addition and subtraction. Okay. Notice on number 28, we have 8x squared y minus 32y cubed. Look for your greatest common factor first. Always, to find your greatest common factor, remember, always take the smaller number. Does that smaller number go into 32? Yes it does, actually, because 32 divided by 8 will give you back 4, and 4 is a perfect square, so you are good to go. So we know that's going to be an 8. Look at your variables. You have an x squared y here, but you only have a y to the third. They both have a y in common, and you would take the smallest one because they both have a y to the first power. So then take 8x squared y divided by 8y. That would leave you with just x squared. Subtraction comes down. 32y cubed divided by 8y would actually just be 4y squared. And then the square root of x squared is just x, and the square root of 4y squared is just 2y. So you factored out an 8y. Inside of your parentheses, the x squared came first, so your x would be on the left side of them. Your 2y came your 4y squared would come second, so your 2y would be on the right side of them. And we need subtraction and addition. Okay. Alright. You would do the same with each one of them. Factor out. Greatest common factor. If they're not already perfect square roots, that means there is a greatest common factor that you can take out of both sets, and your remainder when you take it out should give you a difference of squares. Okay. If you have any questions, I will be available tomorrow from 10 to 12. Let you guys know where as soon as I post this. Or you can always just email me. I will always respond within 24 hours. Normally it's within a couple of hours, and for sure by the end of the day. Hope y'all had a great spring break.